Oblivion Science Brief Number 1. The light itself. What photon statistics can tell us about the most massive black hole ever measured? Light from TON 618 is born in chaos. Hot gas, tens of thousands of degrees, atoms jostling. Chaotic light carries a statistical fingerprint. Its photons arrive in clumps. Laser light does not. This clumping, called photon bunching, is the signal Oblivion is built to read. The strength of the bunching is a single number, G2. Thermal light gives exactly 2. Coherent light gives exactly 1. No one has ever measured this number for a quasar. If any part of TON 618's emission is coherent, a hidden maser, an amplified jet, G2 is the only observable that can see it. And even a clean answer of 2 is a first, direct laboratory-grade confirmation that quasar light is thermal. The clump density also encodes the photons per mode, a quantity set by the brightness temperature of the emitting gas and conserved across 10 billion light-years of travel. Measure it, and you read the disk's temperature directly, with no assumption about the source's size. Every current estimate has to make that assumption. This one would not. And one more trick. Some light reaches us directly. Some whips half an orbit around the black hole first, arriving years later. Same source. Fixed delay. Because both paths carry the same flicker, the flicker echoes. Find that echo in a single detector's data stream. No baseline, no image, and you have detected strong gravitational lensing purely in time. The delay is set by the mass. The echo weighs the black hole. 3 measurements, 1 instrument. The character of quasar light, the true temperature of the disk, and gravity's echo in time. Oblivion. Observing black hole light via intensity correlation. Oblivion Science Brief Number 2. The feeding machine. How resolving TON 618's accretion flow settles a 15-year argument. Gravitational microlensing keeps measuring quasar disks 3 to 4 times larger than standard theory predicts. 15 years on, nobody agrees why. Inhomogeneous disks, scattering atmospheres, non-standard flows, all still on the table. Intensity interferometry measures size directly, and it is naturally multicolor. Change the filter, run the correlation again. Standard theory makes a hard prediction. Disk radius grows as wavelength to the 4/3 power. We test it point blank, color by color. Deeper in, the flow has an edge, the innermost stable circular orbit. Inside it, gas plunges. Where the glow stops is set by the spin, from 6 gravitational radii for a non-spinning hole, down to 1 for maximal spin. Resolve the inner edge, and you read the spin, without the model dependencies that make X-ray spin measurements contested. And a riddle. At 66 billion solar masses, TON 618 sits near the theoretical ceiling, where a disk should tear itself apart under its own gravity before reaching the hole. Thin disk. Bloated Super Eddington torus? Something else entirely? Resolving the flow answers whether the biggest engines in the universe run on standard fuel injection at all. 3 answers from 1 instrument. The disk size argument, the spin, and the anatomy of an engine at its design limit. Oblivion. Observing black hole light via intensity correlation. Oblivion Science Brief Number 3. The edge of physics. What the shape of a ring of light says about space-time itself. General relativity makes an austere claim. A black hole is described by exactly 2 numbers, mass and spin. Nothing else. Every property of the photon ring follows from those 2. Measure the ring precisely, and any deviation beyond what mass and spin allow is new gravitational physics. The ring is really a stack. Light that completes extra half-orbits forms thinner, fainter subrings, each dimmer than the last by a factor of e to the pi, about 23. That decay rate is set by space-time alone. No property of the gas can fake it, and none can hide it. The subring ladder is a test of general relativity with the astrophysics stripped out. And if there is no horizon at all, gravastars, boson stars, fuzzballs, proposed imposters with a surface where a horizon should be. A surface glows and it echoes. A horizon swallows in silence. A deep central shadow with clean subrings is the horizon's alibi. One more prize from particle physics. If an ultralight boson exists near 10 to the minus 21 electron volts, the fuzzy dark matter window, a black hole this large cannot stay spinning. The particle cloud drains its spin through superradiance. Measure the spin of the most massive known black hole, and you rule particle masses in or out. Territory no laboratory on Earth can reach. The ring's shape, the subring ladder, the silence of the horizon, and a dark matter search 66 billion suns wide. Oblivion, observing black hole light via intensity correlation. OBLIVION Science Brief, number 4, the 3% mass. Why one geometric measurement recalibrates 4 fields. Today's number, 66 billion solar masses, comes from gas cloud speeds run through a calibration factor that is itself uncertain by a factor of a few, borrowed from small nearby black holes, and stretched across 4 orders of magnitude. The photon ring is a tape measure. Gravity draws the circle. We read its diameter. Mass to 3%. Every quasar mass in every survey leans on that same calibration. One geometric anchor at the extreme end constrains where the extrapolation bends, recalibrating the black hole mass ladder under decades of measurements. It also sharpens a genuine mystery. 66 billion solar masses, less than 3 billion years after the Big Bang, requires near-continuous feeding at the maximum rate from the earliest possible start. Today, the factor of 3 mass uncertainty dominates that budget. Remove it, and it grew impossibly fast, probably becomes an actual constraint on how the first black holes were born. The same giant masses set the loudness of a nanohertz gravitational wave background now heard by pulsar timing arrays. An independent mass at the very top of the function is a direct input. And one honest caveat, always stated, the ring measures mass divided by distance. Adopt the standard cosmology and the distance costs only 1%, or assume the mass. And the largest black hole in the sky becomes a ruler for the universe. One measurement, the ladder, the seeds, the gravitational wave sky, and a new standard ruler. Oblivion, observing black hole light via intensity correlation.